Hi everyone, this is Pearl Ernest A. Barrera, your reporter number 20, and my topic is periodic motion experiment. Describe the conditions for resonance. What is common to all the motion shown here? That's right, all example of periodic motion. But first, let us define periodic motion. Periodic motion is a type of motion that repeats itself at regular intervals of time. This can be observed in various systems such as a mass on a spring or the orbits of a planet. The key characteristic of period motion is its consistency. After a specific time period, the system returns to its initial position or state. This motion can be described mathematically with concepts like oscillation, frequency, and period. Oscillation means swing of the bob back and forth one complete oscillation. Frequency, number of oscillations completed in 1 second measured in hertz. Period, time taken to complete one oscillations. One example of motion is simple pendulum. A simple pendulum consists of a mass called a bob attached to a string or rod of fixed length that swings back and forth under the influence of gravity. It moves in a circular arc around a pivot point. The motion of a simple pendulum is periodic, meaning it repeats after a certain interval. The time it takes to complete one full swing back and forth is called the period, which depends on the length of the pendulum and the acceleration due to gravity but not on the mass of the bob. The formula of period of simple pendulum is T equals 2 pi the square root of L over G, where L is the length of the pendulum and G is the acceleration due to the gravity. Simple pendulum are often used in physics experiment to demonstrate principle of motion and oscillation. So let's solve the period of the pendulum. Problem. A simple pendulum has a length of 2 meters. Calculate the period of the pendulum. Given length is 2 meters. Acceleration due to gravity is g equals 9.81 meter per second squared. Solution. Use the formula for the period t. Now let us substitute the values. T equals 2 pi the square root of 2 over 9.81. The next step is calculate the square root. The square root of 2 over 9.81 is equals to 0.451. Now let us substitute back. T equals 2 pi times 0.451 is equals to 2.83 seconds. Why 2.83 seconds? Because we multiplied the 2 times 3.14, which is the value for pi times 0.51. So the answer is the period of the pendulum is approximately 2.83 seconds. Now let us describe the conditions for resonance. Resonance occurs when a system is driven at its natural frequency, leading to an increase in amplitude of oscillation. The key conditions for resonance are natural frequency. The system must have a natural frequency, which is determined by its physical properties like mass, stiffness, and etc. External driving force. An external force must be applied to the system at a frequency close to its unnatural frequency. Matching frequency. The frequency of the external force should match or be very close to the system's natural frequency. This allows for constructive interference of the oscillations. Damping. Low damping is preferable as high damping can dissipate energy quickly and prevent significant amplitude increases. And the last one is energy input. The system must receive continuous energy input at the resonant frequency to sustain the oscillation amplitude. Now that I am done to discuss my topic, let us recall what I have tackled. Periodic motion. Periodic motion is a type of motion that repeats itself at regular intervals of time. This can be observed in various systems, such as a mass on a spring or the orbits of planets, and it can be in a simple pendulum. The motion can be described mathematically with the concepts like oscillations, frequency, and period. Oscillation, swing of the bob back and forth, one complete oscillation. Frequency, number of oscillations completed in 1 second measured in hertz. Period, time taken to complete one oscillations. To get the period of simple pendulum, we use the formula T equals 2 pi the square root of L over G. Thank you for your time and thank you for watching. I hope you learned something from me.